Hey guys, so I'm back with another video, and this video's topic will be over inverse functions. So let's go. So, in essence, an inverse function is just the normal function reflected over the line y equals x. So, in graphical terms, you just switch the y and x like this. So, this is the normal function, and then this is the inverse function in terms of coordinates. And you can see that with the graph on your left over here. Okay, so let's actually do a precise definition, and let me read it. So let f and g be two functions such that f composed of g of x equals x for every x in the domain of g, and g composed of f of x equals x for every x in the domain of f. Under these conditions, the function g is the inverse function of the function f. So really, what that is all saying is that if you combine these two functions together, they will cancel out and you have x left over. And the notation is important too. So the notation of an inverse function is f to the negative 1 power of x. So this is the inverse function. There you go. And then the bottom is just re-saying what's here. And another important tidbit is that the domain of f is the range of the inverse, and the range of f is the domain of the inverse. So it's just saying the domain and range get swapped, like the x and y values. Okay, so let's do our first algebraic problem solving for inverse functions. So you're given that f of x equals 4x. Now find the inverse function. So the first thing you want to do is take this f of x and make it y equals 4x. So it looks like a graph, right? And then since the inverse swaps the variables, you'll just do that. So you have x equals 4y because this is a reflection over the line y equals x, and I just did that. Now just solve for y. So just divide by 4 on each side. So you have the inverse function of x equals x over 4. And you can prove this too, because if you combine these functions together or compose them, you will find that the 4's cancel out and you have x left over. Okay, so this is really just proving what I said earlier, because they give you the function and the inverse, and all you have to do is just plug it in as they want to do it. Find that the 4's cancel, you have x, and then vice versa. And this is really just basic composition of functions. So if you don't get how I did these two problems, you should watch the third video in this series in Algebra 2. Okay, so let's do a harder problem, but it's still not crazy hard in my opinion, and I will show you guys how to do this. So the first thing you want to do is, again, make this a y equals function, right? Swap the variables. So now you have x equals 5 over y minus 2. Then solve for y. Multiply by y minus 2 on both sides. So you have x times y minus 2 equals 5, because these cancel out. Then divide by x, right? So you have 5 over x equals y minus 2. Add 2 to both sides. So you have 5 over x plus 2 equals the inverse function. And as you can see, I can answer this question by saying that h of x is the inverse function to f of x. Okay, So this is the test to see if the function has an inverse function, and it's the horizontal line test, and it states that a function f has an inverse function if and only if no horizontal line intersects the graph of f at more than one point. So look at this x cubed function. See that the horizontal line will only intersect at one point, no matter how you really splice it, and that proves that it has an inverse function. And another property of an inverse function is that it's one-to-one. And a function f is one-to-one if each value of the dependent variable corresponds to exactly one value of the independent variable. And a function f has an inverse function if and only if f is one-to-one. So if f is not one-to-one, like the graph x squared minus 1, it will not have an inverse function. So let's do these two problems to finish up our video. And the first problem is f of x equals 5 minus 3x over 2. So make this a y equals function. Swap the variables. Then solve for y. So how you solve for y in this case is that you multiply by 2 on each side. So 2x equals 5 minus 3y. Subtract 5. So you have 2x minus 5 equals negative 3y. Then divide by negative 3 on both sides. So you have that the inverse function equals negative 2x minus 5 over 3. And the other question, don't let the square root function scare you, because it's not that hard, or the cube root in this case. So again, what you want to do is make this a y equals function. Actually, let me do this in a different color. Here. Swap the variables. So you have x equals the cube root of y plus 1. Then solve for y. So the first thing you want to do is cube both sides to get rid of the cube root. These cancel out. So you have x cubed equals y plus 1. Subtract 1 from both sides. And you have the inverse function equals x cubed minus 1. Not hard. That wasn't hard, wasn't it? So that's it for this video, and see y'all in the next one.